So the next thing we're going to look at is aggregates or statistics. These are regular functions, all right? But we basically call them aggregates in a sense because it's basically regular statistical functions that we usually use. Now, just like any function in any programming language, the standard format or the standard syntax is always you have your function, you open parentheses, and inside of there you have your arguments, right? Any programming language you do will always look like that, right? So it's the same thing. If we wanted to, you have the regular ones, you have the average, sum, count, max, and min. And I think you also have the standard deviation as well. So let's say we just wanted to demonstrate a few things. So select the average, let's say the average quoted price, right, from the order underscore line table. And let's call this as average quoted. These need to have some underscores between them. So let's say we did this. The average function requires us to change it. I'm not sure why, but it just does, right? So we will have to do dot dot numeric. Okay, so we have to coerce it. You don't get these problems in SQL Server, by the way, only Postgres. So if it does that, it actually gives us this value. It looks kind of horrible and ugly. So what we want to do is we want to just basically format it a bit, and to do that we can do a round function. Right? So the round comes on the outside. After this parentheses, we'll do a comma. And you have to specify how many decimal points. So we'll do 2. So now, when we run this, now you can see the average is 320.55. We can do a sum as well. So the sum of the quoted underscore price. All right. As total underscore price from order underscore line. And surprisingly, you don't actually need to change this over here. I'm not sure why the average it operates differently from the sum, but it is what it is, right? So now if we look at our order line table, select star from order line. So this is 2,884, right? So if we were to look at our order line table, if we add all of this up, it should basically give us this result. And likewise, if we were to do an average of all of these, right, if you were to do an average of all of these, you would come to this result over here, which is 320. So now let's also look at the max and the min. I'll do it in one line. So max quoted underscore price as maximum. We can do a min as well. Min quoted underscore price as minimum. From the order underscore line table. And if I run this, we can see the maximum, the minimum. We can even put in, if we wanted to, the sum. Okay, so we can do this as well. All right, and if we run this, let me put it in a different line actually. So if we run this, we should see our total price as well. And I'm not exactly sure, but I think we can also do the average, but I can't remember if it will work or not. If it does, great. If it doesn't, well, it just means that we can't do it. I can't remember if you will get a conflict because of having to coerce it. Nope, you don't get a conflict. So here you can add in all of these if you wanted just the basic statistics, all right? And this is how it is you would use aggregates. Now, another thing that we need to be aware of in SQL would be you can do a count as well. So if I wanted to count the number of names, for instance, so select star from customer. If I did select star from customer, right, we know that there are 10 records, right? But let's do a count function for it. Let's say we had some let's say we had some number that we didn't know, like some number of records that for whatever reason we didn't know, or they just kept going on forever. You can just do select count of the last underscore name, okay, from customer. And if you were to run this, you'll see that it tells us 10. But there's another function that I want to introduce you to, which is called the distinct function. And what the distinct function does is that it allows you to see how many distinct values there are. So if we were to run this, for instance, you would see that Adams, Samuels, Charles, Daniels, Adams is twice, right? So if we were to put distinct, remember we first got 10 records. If we were to put distinct in this case, now it would be reduced to 9. Another way to demonstrate the distinct function, if we were to look at select the select star from order underscore line, right? So if we were to look at all of these, you would see that it gives us basically, it gives us all of these. If we look at the number ordered, you would see some of them are just 1, right? 11, 1, 1, 4, 2, 2, 4, 1, 2. If for whatever reason we didn't want all of these repetitions, or we didn't want all of these numbers, not that this makes sense, this query does not make any sense at all. This is just to demonstrate how the distinct works. If I were to do select the sum of the ordered numbers, so I'm just going to copy and paste this over here. Again, this is just simply just to show you how the distinct works. So if I run this, you would see that it tells us 28, right? And why does it tell us 28? Because we are adding all of these numbers up: 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. But if I were to do distinct inside of here, again, this is just so that we can see how distinct works. If I were to do distinct here, now it gives me 18. Now, why does it give me 18? Let's look at this overall table, right? If we were to do 11, 12, 13, 14, 15, 16, 17, 18, and then the rest of numbers are repeated again, so that's why it gives us 18. Again, this doesn't make much sense in terms of the query itself. Doesn't make much sense. There's no actual use of just counting the distinct number of orders, but it's just as a way of us from understanding how distinct itself works. All right, so all distinct does is that it does not count the repeated values. And count function again allows us to count text or string data, or basically varchar or variable character data. And that's pretty much how you would use the aggregates in SQL.